The second session that we've got planned here is going to be led by our colleague Francisco Campuzano, yep. And we'll be looking at the use of the EDITO-Model Lab setup to actually go through various what-if scenarios for different ocean conditions. So I will hand this over to you.
This is for passing the
green to go forward, red to go back.
Okay, okay.
And all yours.
Okay. I don't have much slide on my side, so okay. So thank you very much and for having us this afternoon. We are going to talk about the EDITO-Model Lab what-if scenarios. So the idea is that when you leave this event, you have a more clear idea of what can be done with the digital twins and to support the stakeholders. I mean, just to give you a very brief overview, the idea is that these what-if scenarios, they help us to shape and to co-design with the stakeholders what we can do and what are the type of events that can happen, so we can take a better informed decision. And here we will have a setup of experts, and these experts are going to present you some examples that are developed on the EDITO-Model Lab, and also you will have a presentation of the background, and because the project is much more than what we are going to present today. So for this we have Yann, Drillet, that is the leader of the project, the coordinator, and he's going to present.
Yeah. Good afternoon. Does it work? Yeah. Okay, so yes, I'm Yann Drillet, the scientific coordinator of EDITO-Model Lab. I just plan to give you a very brief introduction about this project. Then there will be other presentation and explaining new results. So what is EDITO? It's this European platform developed as a backbone of the European digital twin of the oceans, really to discover, visualize, leverage product and knowledge, and really to develop these powerful tools. And so I have a brief video to introduce the main concept of EDITO Platform.
EDITO is the public infrastructure for the European digital twin ocean. It offers you high-quality marine data on a cloud computing platform you can access anytime, anywhere. Whether you're using EDITO to build digital twins, contribute your own services, or explore marine data, let's see what EDITO can do for you. Imagine an environmental modeler with a mission to protect the coast from rising sea levels. Using EDITO, he can simulate different solutions, from growing seagrass meadows to restoring shellfish reefs or salt marshes. Armed with this knowledge, he can help policymakers select the best option for the future. You can also contribute your data and services to ensure lasting impact. Picture a project manager working to develop tidal energy sources. Her team has developed a new digital twin for designing tidal turbines. But what's the best way to share this tool with new users? By adding her services to EDITO, more people will access and build on this work, growing the potential of clean energy across Europe. You can also use EDITO to explore a wealth of marine data. Back on land, a marine data scientist is studying European turtle populations. But what's the best way to track their movements in the wild? With EDITO, she can access interactive data on ocean currents, water temperatures, and potential threats. EDITO grows her knowledge of what it takes for species to survive and for protecting biodiversity going forward. And that's not all EDITO has in store. As the community grows, more and more digital twins, applications and services will build a shared foundation for ocean knowledge and sustainable action. Take the leap, join EDITO and grow the European digital ocean community.
Okay, so that's really the main concept of EDITO, and then we will present what has been done in EDITO-Model Lab, which is really one component to develop new modeling tools and so on. So, sorry, I haven't said that EDITO is also now a UN, is really part of the UN decade with this action in the framework of what we call the EDITO program in this UN decade framework. So EDITO program is an international organization to coordination of development of digital twin all over the world, and EDITO is a European component for this part. So now moving to EDITO-Model Lab. So that's a consortium of this project with a lot of experts in different high-level activities and very expertise in terms of numerical modeling, supercomputing, artificial intelligence, software development, and a strong link with operational oceanography at European level. And we have also a lot of activity to design with and for the users the application. And it's what will be explained just after in terms of what if scenario that we can develop within this platform. So that will explain what kind of data we will use, what are the models, how we can use computing resources available on EDITO platform to define really new services and on-demand processing. So today we will talk about the what-if scenario. It's really a workshop for the end users to explain what kind of what-if scenario we have developed and could be used already on the platform. And then there will be another session at the end of the UNOC meeting, so 13th of June, to start a hackathon framework, especially for intermediate users, focusing on specific application. So that's it for me, and then I leave the floor to Joanna.
Now we have Joanna Staneva from Hereon, and she's the work package coordinator of the what if scenarios. She's going to explain us a little bit more of the concept.
Yes, good afternoon, Does it work? Yes, good afternoon, everyone. We have heard what is the EDITO. We have heard what is the digital twin. Digital twin of the ocean is indeed the digital representation of the ocean. And why we need the digital twin? We need the digital twin because now our Earth is suffering to climate change, sea level, marine stressors. We need immediate decisions. And sometimes having a forecasting system is time requiring, requires much more computational resources. And in order to have the easy resources and also quick decisions for the digital twin platform, the what-if scenarios are developed. The what-if scenarios, they are in the core of the digital twin of the ocean. The what-if scenarios are not simply forecasting platform of the ocean. The what-if scenarios are defined by users, stakeholders from the very beginning. They are really aiming, having quick decisions. And the quick decisions, they have also to come almost immediately, and they have also to serve the society needs and society problems. The what-if scenario also have to be valuable, they have to be trustable. In order to be trustable, they have to be developed together with the users, together with the policymakers, together with the stakeholders from the very beginning. And in order to have the quick solutions for decision makers, they have to integrate in a smarter way the novel observations, hydrodynamical models, as have been already presented into the EDITO. They have to integrate artificial intelligence, machine learning, in order to have quicker solutions, for example, for visualization, for risk, and for mapping, and the visualization. And once this integration is done and they are developed, they can really serve the society needs, and then all end users, they can play and they can have their own questions even before going to the intervention. This is what you are going now to hear with the follow-up demonstrations. And most important, all these demonstrations serving the society needs, they also had to contribute to the Sustainable Development Goals. And the what-if scenario that we develop within the EDITO-Model Lab project, they are developing and contributing to the many Sustainable Development Goals, and how they can really help. They can really help by tracking the different social challenges. I already mentioned, they have to provide a very easy access. They have to be user-friendly, therefore they have to have a user-friendly co-design, because the users who are not experienced modelers, they are end users, they are stakeholders, they are industry and society, they have to be capable to understand from the very beginning the what-if scenario in order to play it, and in order really to explore it. And they can explore it in a different way. For example, to assess the different risks for coastal flooding and how nature-based solution can contribute for protect it, or they can also contribute for having decisions where to install the offshore wind plants, or how to use it, the different marine resources like offshore wind together with low trophic level aquaculture. And we are not talking now for too many what-if scenarios, but in the next half an hour, we will focus on the demonstrations that are the core what-if demonstrations into the EDITO-Model Lab projects. And namely, they are connected with the nature-based solutions for the coastal erosions. And then the user can ask themselves the questions. What if we reconstruct seagrass for protecting the coast? And then with the what-if scenario, as you will see, then the user can have the different solutions to play with. The second what-if scenario, this is on marine plastic for zero pollutions. And then the user can ask the questions, what if we could capture plastic from the rivers even before going to the sea? And then going to the specific geographical area, the user can get the direct question. The third what-if scenario is connected with the blue economy and how can we use aquaculture for the zero carbon. And one question of such is, what if we upscale aquaculture in offshore wind park? As mentioned, this what-if scenario, they have to be user-friendly. This is why we not only provided what-if scenario into the EDITO-Model Lab project, but also provided tutorials and detailed documentation. You can scan here the information and have access to all tutorials and the documentation with the what-if scenario. And now I will give the floor also for the what-if scenarios to be presented.
Okay, thank you very much, Joanna. I think that now everyone get a clearer idea of what is a what-if scenario. And now we have some experts that are going to explain us more on detail. So first we have Wei Chen.
Thank you very much. My name is Wei Chen. I will introduce more in details as an example how what-if scenarios applied for the end users. When we come to the coast of the oceans, the main hazards we meet is the coast erosion, floodings, and traditionally the idea is we construct hard and grease structures to protect our coasts, but alternatively the nature-based solutions becomes more and more popular. For example, the mangroves on the beach, the salt marshes in the tidal zones, and the seagrass further in the seas. And why these solutions, nature-based solutions, become more and more popular is because of not only for the economy purpose, but also the ecological values and tourism values. First of all, it helps, like the traditional works, it helps to reduce the waves and currents if we plant them in the seas, and also it helps to stabilize the beaches and weakens the coast erosions and floodings, and also as a side effects, it's more environmental friendly and help to bring more tourists to the coasts. If you don't want the tourists stand by the beach and see the hard grey structures. And we applied the seagrass applications in several locations, not just in 1 or 2 locations, but also like the Wadden Seas, Adriatic Seas, the Black Seas, and also the Ghana coasts. And in the next the videos, I will talk more in details.
Be customized to your needs, whether that's seagrass meadows in the Wadden and Adriatic Seas or mangrove forests off the coast of Ghana. We can create priority risk maps and generate knowledge of where nature-based solutions work best. This empowers decision makers working to protect their coasts. With this tool, you can create what-if scenarios.
So this is the example of what-if scenarios used in the Wadden Sea case. So here you see this is a risk of erosion with different colors. You classified low risks, medium risks, and high risks. And what if we use seagrasses? As you can see here, you change the density, the position of the seagrasses, and then you see the distribution of the seagrasses and how they help to reduce the different physical parameters like the waves and the erosions in different colors. And so here you see for different the classifications. And also, it's just not only for one scenarios, but you can cross-comparing with different scenarios. For example, here we compare the case with more dense transplanting seagrasses at this area compared to less dense planting seagrasses. And you can see by shifting the screens, you see how the difference will be. And here we also show you transferable examples, not only in Wadden Sea, but here in another location, the Ghana coast. And what if we reconstruct seagrass, and how will they react in our coast? And similar actions you can do here as well. And you see we change for different parameters, and then you zoom in, zoom out to see the more details.
With this application, the ability to test nature-based solutions that are tailored to users' specific regional needs is groundbreaking. Decision makers will be more informed about using vegetation to reduce erosion risk and wave heights on the coast. This in turn helps reduce the cost of coastal protection for.
Like we said, the nature-based solutions is not dead. It adapts to your local ecosystems. When the sea level rise, it also adjusts to the tidal flats. Here is a video how the seagrass is planted, and it will live and gradually grow. And for more details, please follow our research. Thank you very much. And we go on with the next applications.
Thank you very much, Wei. And we continue with another case study that is of what-if scenario.
Yes.
Of James Murawski.
Can you hear me? Yeah, fine. Hello. Good day. I want to present the what-if scenario on marine plastic pollution. And first of all, I think I should say, what is marine microplastics? So marine microplastics is all particles or fragments smaller than 5 millimeters. And most of them are actually much smaller than 5 millimeters. So in the micrometer range, that's why the name. And why they are so dangerous or have such an impact on the marine environment, that is because they spread very efficiently in the environment. So you have them basically everywhere in the deepest part of the ocean. And they are very easily uptaken by animals and processed, and this inhibits their ingestion. Also, they can carry toxic agents and so on. The list is quite long in the ways they can affect marine life. And for this reason, we would like to reduce the marine plastic pollution in the vulnerable areas in the sea, like that's marine protected areas. And therefore, we have developed this application. So this is an example just from the little Baltic Sea. Every year you get 9,000 tons of tire wear microplastic. So that's from car tires, abrasion, that enters the sewers and so on, and finally into the sea, 9,000 tons. And about 75,000 tons of household microplastics. That's cosmetics, that is fibers from laundry wash, and so on. So all this is entering the Baltic Sea. And this makes it very difficult to actually combat marine pollution, microplastic pollution, because not just that the particles are very small, there are also quite a lot of them. So for this, we have been developing this what-if scenario using our models. So that's our models describe how the microplastics are released into the environment, how they're carried around by the currents and actually also by the waves. And then finally how they interact with the environment to finally settle or sink and settle on the sea bed. So, and with this we can ask, doing these microplastic simulations is actually one of the first times where the microplastics are visualized, so where you can actually see what the pattern of the transport are. But doing this, we can ask ourselves, what is actually the impact of cleaning? So when we release the microplastics and they are transported in the environment, how is reducing the microplastic at the coast affecting the concentration at the sea? Because that's not a trivial question. And how much reducing this will impact the concentration? So this is the first question. But then actually we can turn all this around and we can ask ourselves, looking at the vulnerable areas, looking at the marine protected areas, what is required to clean or to prevent that microplastics enter these areas? So we can look at how the individual rivers contribute to the pollution there. And then we can ask ourselves, what do we need, or we know what is needed to be done to clean the microplastics. So this is now an example for tire wear for the Baltic Sea. So how the pattern looked like for one river, that's the Neva River, that's the biggest river in the Baltic Sea. And that's just an example. You see the Neva is at St. Petersburg, there in the east, and this is 1 year of simulation. So after 1 year, the microplastic have basically spread everywhere. You find them in every basin of the Baltic Sea. But then you can think about what will reducing the microplastics mean. So reducing 80% of the microplastics will produce pattern that look like the pattern on the right side. And that is a much reduced pattern. You see the concentrations are much lower. So if you have a marine protected area, the outside near Gotland, then you will rather go for the 80% scenario, because that's where no plastic enters your protected area. So this is the demo that we have made. Okay, it's already running. So you can access this on the EDITO infra. So you can run this as a desktop application, and you can add rivers, and you see there's a Neva River, and now you have added a Vistula River. You can reduce the pollution by like 8% to 20%, and you can see immediately how the pattern look like and how that changed. So you can also play around with it. You can enable all the rivers, and you see how the pollutants or how the pattern look like in the Baltic Sea. Oh, this is not all the rivers. There are 450 rivers in the Baltic Sea. This is only the major ones. And then you can look at this at the surface. You can also go to the seabed, and you can also look at it vertically integrated over the whole water column. And then you can look at tire wear, that's what we have been looking now. And then we look now at near the seabed at household microplastics. So you can go through the portfolio of microplastic particles and you can play around and you can see what cleaning action will actually bring to the marine pollutants offshore. So this is how the concentrations look in the southern Baltic Sea. And then coming to the next application, we have made a dashboard application where you can actually see for all the marine protected areas, what is the concentration of the microplastics that end there and where are they coming from? From which rivers? On the right side, you see a list of rivers from the largest one, that's the Oder River there, on the top to the bottom. And yeah, going through the marine protected areas and going through the fractions of microplastics, household microplastics, large, small, or tire wear, you can see how the concentrations change in your areas. And on the top, you see for all three fractions, what is the ratio between them. So you see tire wear, that's the smallest fraction. They're heavier, they sink on the bottom, and household microplastics, they are initially buoyant, and then finally, overload and sinking to the sediment. So that now the animation is starting again, so you get the benefit of having it again. But yeah, this is what we can do. We can provide information about what you have to do to really change the microplastics in your area. So we enable basically targeted action for the marine protected areas that you have there, where you know or you learn what you have to do to protect these areas from microplastics. So that's kind of the end of my presentation.
Okay, thank you very much. Now we have, last but not least, we have Lorinc Meszaros, that he's going to present the final what-if scenario about aquaculture.
Thank you, Francisco. For a bit of change, I will stand here. Otherwise, the other side of the room will feel left out. So Jens wanted to say that you can explore the application via this QR code. So now I would like to continue with our last application, the last what-if scenario. And in this one, we want to answer the question, what will happen if we upscale aquaculture farms in the North Sea inside wind parks? That is the main question that we would like to explore. And that is interesting because here in the Mediterranean Sea, I think there is a bit more space, but up in the North Sea, there is really limited space. That means that for the energy transition, we are deploying more and more wind parks, but there is no space left for other activities. So there is the question, what to do with that space? And that space can be used for multi-use, but multi-use can mean offshore solar wind farms, can be seagrass, can be used for tourism, or we can also use it for shellfish aquaculture. And that obviously has the benefit of growing the blue economy, providing jobs. Obviously, it provides food. It's actually one of the nice things you can eat in the Netherlands, shellfish. But what we want to explore in this application is really if it could also store carbon. Does it make any difference at this scale? Or would we even create a bigger problem? So this is what we wanted to explore here. And as with my colleagues, I have a video to show you how this works, and I will explain it as you watch it. First of all, you can access it through the usual EDITO Platform interface by typing Aquaculture Impact Assessment. And you can read more about it or directly run it. So our application is an interactive dashboard where you see all the offshore development plans, the wind park names, their suitability, and their distance to cost. And you are allowed to choose a scenario of either an operational park or planned or even considered research parks and the deployed aquaculture area within it. Obviously, if you select more wind farms, you will have more aquaculture area. And then on the right side, what you see is the impact on carbon fluxes. The shellfish itself generates carbon and also takes carbon. So what is emitted to the water, it can end up in the seabed, it can end up in the water or in the atmosphere. And what we want is, if it's harvested, would that be temporarily stored or maybe even long-term taken out? And that means that you could save and store carbon. And that's why we have also a main panel to inform the user on what would be the net carbon impact of the different upscaling scenario. If it's negative, that means we save carbon. If it's positive, we could even generate more carbon. And how it is related to Dutch fishing fleet emissions, to give you a bit of sense of the amount. And obviously, ocean carbon will also affect ocean acidification. So that's another panel we included, because we want to also know, if we upscale aquaculture, will we remain in the healthy pH level, or will we influence the water to be more acid or maybe too alkaline? So that is the concept behind it, and this gives you an impression on how to explore all these modeling scenarios. And then finally, there is a bit of scientific context behind it if you are interested on the technical tools, the assumptions, how we calculated suitability, and you can read more about it. So this was the main concept, to make something really complicated into a simple dashboard. And so far it worked. We have asked related NGOs in the North Sea. One is called Stichting Noordzee, which is the North Sea Foundation. And they said that the really simplified way of expressing carbon budgets really helps them, especially in the North Sea Agreement, which is an agreement between the Dutch government, offshore wind developers, and also environmental NGOs. They have to discuss how to allocate passports, so basically permits within the offshore areas, and what kind of multi-use option to take. So they said it would be very useful. They even said that soon in the Dutch Parliament there will be a roundtable discussion on this topic, and they would really like to have the scenarios done by then and really bring this to the table. So I think this shows that three-dimensional, difficult, complicated models can be really used for scenario analysis and simplified to the extent that non-experts can also visualize it and use it as a tool for discussion. I think that's the most important, because without any evidence, it is difficult to discuss these scenarios. So thank you very much. And as with the others, you have the opportunity to take a picture and explore our dashboard. You don't need any account for that. Thank you.
Thank you very much, Lorinc. We are very good of time, which is good news. So also I will call for the speakers to come to here to the table so we can ask them some of the questions. But something that I wanted to show you first is that we have set up one Slido where we want to collect also your feedback. This Slido will be open during the next week. So please copy the code or answer it as soon as you want. But basically, we want to know how do you feel with the added value of the EDITO-Model Lab to your work? If you feel ready to use the EDITO, what do you need to start using it? And what other marine challenges would you like to address? So these are comments that you can put here, but you can take also now the opportunity that we have here the experts to ask them some direct questions. So please, anyone? There is no, okay, right. Talk close to the mic.
Sorry. Thank you very much. I have not the chance to follow all the presentations, and I present myself. I'm Hussein Ibeni from Morocco. We have a marine observatory, a baby marine observatory. However, we use gliders and systems, and we are working on the inclusion of citizen size to the mussel farms we have next to our marine protected area. So I'm just discovering what you are doing, and I might need some help to update what we are doing. Thank you.
Anyone want
Yes,
to
thank you.
comment? First, they're going to... Okay.
No, I can say just a few words about this EDITO platform that is available for everyone. So today you can already use it. You can also upload a new data set and share this data set with external collaborators, or only for your project if you want. So it's what has been explained in the short movie just at the beginning of this session. The different concept of how you can explore all the database and so on, or you can contribute, providing new data also, or new tools, new modeling component, and or you can build your own application using what has been developed, for example, in EDITO-Model Lab, because all the model components that we have developed in EDITO-Model Lab are already available on the platform on a specific GitHub, and everybody can already upload codes or use it for other applications and so on. So that's the plan.
Thank you, Yann. Also, I will call the attention of the event that will be next week, where they will be also presenting the hackathon and the focus application. So if you are here, please come. If not, you can also attend online. You have a question?
Yeah, thanks a lot for the great presentations. I have a general question to start. How can you best test and validate your what-if scenarios to check that it would be accurate if it really happened?
As we call it, the what-if scenario. So you need to run as much as possible the experiments, the scenarios. For example, our case, the seagrasses, we need to cover all the possible distributions of the seagrass for the given areas. For example, we run for more than 200 experiments, but that will be very computation expensive. So instead, we also involve AI techniques inside, and we only run part of it, and then we use that data to train our AI, and then use AI to do the simulation, the other simulations, and this will largely increase the efficiency of the applications. This is, but the final purpose is, again, we try to find the most optimal seagrass layouts for this location. And this is for different applications, different locations. You will have a different landscape, different hydrodynamics forcing conditions. So you need to build up your own applications, but the framework, the ideas is the same.
I can add something for then. What is very important is that our applications and our tools are trustable. We are well aware that observations have errors, the model have errors. We did the EDITO-Model Lab, as explained at the very beginning. Also, we developed validation tool in which we showcase that all models that are integrated and all applications, they're well validated. And the users can also see that. In addition to that, of course, the uncertainties have to be communicated with the users in the understandable way. And this is also what we are doing from the models observations, model observations AI, and the what-if scenario. Of course, what-if scenarios themselves, they go beyond the simple nature, because what we validate and what we assess is against observations that are available. But the sweet point in the what-if scenario is that the user themselves, they can make any kind of climate scenario, any kind of intervention scenarios. And those intervention scenarios themselves, as well as many parameters, they're not directly validatable. But we rely on the models and tools that are already validated in order to provide the different scenarios with the different levels of uncertainties.
Yes. Actually, I wanted to say the same thing. So what shall I say? I mean, of course, our models, you know, they are validated, and we use them. I mean, we use here a tremendous amount of computational time and work to produce all these scenarios, alternative scenarios. But the point is that the models behind, they are validated, and yeah, with this we have some understanding of the uncertainties of the process, and for that reason we have a kind of we feel safe that this is something that is trustworthy, that we can provide to the users.
Maybe just a last addition, that I think there is still one trick that we can use, is to go back to the past. So for example, in the Dutch part of the Wadensee, there is not much seagrass left. So whenever we are talking about restoration, nobody knows what would happen because it's not there. But we had it 100 or 200 years ago. But when we sealed off an inner sea with an afsluit dike, that completely changed the patterns. So when our ministry asked about where should we restore seagrass, we had to start with the historical records from the 1800s. We still had, fortunately, some oceanic, not digital recording, but maps. And we tried to recreate those conditions and then implement the dike in it, how that changed. And that's how you validate a what-if scenario that otherwise you cannot. So at least time travel could help you. Yeah.
Thank you. Any more questions from the audience? If not, I have, yes? Oh, sorry.
So these applications look amazing, and there's really, really good stuff with the dashboards that have been created. I was wondering if there is room for further tooling in terms of actually being able to take and interpret that data and effectively produce sort of textual outputs or things like that that will actually, you know, help the decision makers a little bit further than, you know, their own expertise in understanding the dashboards.
Yeah, I can answer from one perspective and then you contribute. I think the first one is that although all of our scenarios and applications obviously are really credible, our idea was to really build the engine of the digital twin and demonstrate it. So unlike other projects who have 5 years of user engagement, we had much less. So we wanted to have a nice product to demonstrate what our models can do. And that's how we ended up with these tools. But obviously, what's important that the components that we have are reusable. So you could stop here or you could continue further. So there is potential, the data is there. Every application would then need another user interface. So that's a bit difficult question where you stop in creation and iterative improvement. That's where we could stop, and there is much more behind it, obviously. You could continue.
Well, actually, the end of this EDITO demonstration is the beginning of something which is useful for the users. As already mentioned, they all are made as co-designed with users and stakeholders, but this never stops. Show must go on, and we always continuously develop. We develop a new scenario because they are user-based, they are stakeholder-based, decision-maker-based. Also, based on the feedback that we also expect to come now, we will improve then, we will improve our visualization tools, we will improve our scenarios, and this is the way how actually what-if scenario really differ from the simple forecasting system, is that from the very beginning until the end, it's always the two-way interaction from the developer back to the users and stakeholder, and then back to the developer and so on. Even though those three demonstrations now that have been presented, and they were showcased in a way to fit the Ocean Mission goal for the European project, they are continuing developing.
I can maybe still add that at the 13th of June we will have the hackathon, and there we will look into the focus applications of EDITO, and actually all the microplastic data that we have there, they are also in the focus application, so you can actually access them and play around with them, and in the hackathon there will be tools developed for further accessing them. So the data is there and you can use them, and the what-if scenarios, they are kind of products that are built on top of these.
sorry to add the other question so we were in two projects, Odyssea project and Iliad in digital twin, and during 7 years we are trying to build a real platform for end users and deciders. So it's not frustration, but inside this project we have not this possibility to fly on our own. So maybe with this program you have, we might find a kind of solution to have add value for all the work done, because we are nearly the only marine observatory in North Africa that has been able to have systems, gliders, and and deployed them. And so it would be very interesting to link with the projects in European Union to have this impact. Thank you.
Yeah, sure. There is plenty of projects funded by the European Commission, and it's clear that EDITO projects, we try, at least in EDITO project, to connect most of the other components that develop new modeling tools, that develop a new data set, new observation, and so on. So in EDITO-Model Lab, it was not at all the topic. We are really developing modeling tools for specific application and demonstrated that these models using new computing resources, new type of cloud computing, so that there was also a lot of technological challenge in this project to optimize the code that we have on the different platform and so on. So that was really the objective for EDITO-Model Lab. But now we want also to connect within this broader project EDITO all the other components and all the other European projects. So that's a great opportunity to integrate, and not only the European partners, of course. It's not made only for the European partners.
And the core of the digital twin is to be interoperable and easily accessible. And there are indeed many applications, and there will be many to come. But what is very important is first all those applications to be relocatable, all data to be harmonized and interoperable. And there will be European initiatives in which what you have done can be integrated. But in addition to that, there is UN Ocean Decade Program due to the digital twin of ocean. And this UN Ocean Decade Program actually really targeting, synchronizing all different developments, increasing and enhancing networks between the community all over the world. And you are invited also to look at it, to join. There are working groups from one pillar, from another there is also the use cases. So the different contributors can join either contributing to the working groups or use cases. And currently also within the UN Ocean Decade, there is a call for program and actions, and everyone can apply and being endorsed project under the EDITO.
I also have, a small reaction, because I was with you in Odyssea, and I know very well Iliad, and we had at some point a meeting where we really explained what EDITO is about, and somebody from Iliad finally could catch a breath that, okay, it is not really competing, it is complementary. Because whatever you did is not lost. It can be put there, or you can pull components from EDITO. So it is really not about suggesting the best digital twin that will rule them all. Instead, it is really about advancing the different components, and then you can put your Lego pieces together. So whatever you have done in your past 7 years is not lost, for sure. Yeah.
Thank you. Any more comments or questions? I mean, one thing I wanted to mention also is that this is the EDITO-Model Lab, but there is a sister project that is the EDITO Infra, that was building the infrastructure where all these applications have been put into place. So and this is also the idea that that we'll be presenting next week about other intermediate users, how they can place their own applications in the EDITO family of projects, or how they can learn how to do it. And this is also a question that I have for you, like, because we didn't go too much into the detail of the modeling or of everything, but in fact, each of them are using different engines, and I would like to know what were the challenges from the very beginning of the project on setting your applications in the EDITO platform, and how do you feel now about it? I mean, do you think that now is a much easier? I mean, after all this time, is something that really improved? Is getting much more easier, more accessible for other people?
Well, this is a quite tricky question. Yes, now we can see we have achieved something, and it's not very easy to see at the beginning. And at this stage, I will say it's just one small step to the final goal. When we're working on this and step by step building up the packages inside the model lab, we feel that we achieved, but not as what we expect at very beginning. But we during the work we have more ideas, and we have something in mind how to improve it and how to continue with this, and this is also the achievement of the project, and the ambitions or the motivations for continue our work.
Hello, yeah. Francesco, as you mentioned, there are two sister projects, EDITO Infra, who hosts the platform, and EDITO-Model Lab, who develops the application. And I think we both have been kind of growing together. We, from the application side, we would like to bring our applications to the platform, but also from the platform side to take up our applications. So I think now it's much easier to do this than it was before. And I think, I mean, the project is not at the end, so I think in the end it will be much easier than it is now to do this. So I think we are improving on both sides to achieve this goal.
If I may, I also have my take. I'm personally really proud with what we have achieved, because if I look back to the Odyssey times, when you all set out, I don't know how many observatories there were in many African and East Mediterranean countries. 9. Yes.
There were 4 in North Africa, in Morocco, Algeria, Tunisia, and Egypt.
Yeah.
So I'm not that proud that the unique one was ours in Morocco, because it doesn't serve, since that we cannot complete the southern things. So for example, we have been able to work on the gyres in Alboran gyres with the glider for big mission with Alcimar. So it was maybe the relevant thing in Odyssey projects.
Yeah.
And then we had implied with, there was 28 partners in Odyssey, and then 56 in Iliad. But the problem is the communication between 56 partners. So this is the kind how we can, because everyone is in work packages with tasks, etc., in terms of developing the activities. But at the end, the impact is how we might take advantage in the south. And I think this very important thing, even for the others observatories that would have the chance to launch again. So I think this kind of, I am here, sorry, I speak too much, but I am here, being here just to defend this, because there is many other things who are not really linked to real pure science. For example, the governance. For example, I've been able to have national institutions in Morocco that are more, there is more fluency in Morocco than other countries. So there is other things, and I think that to have a successful observatory in Morocco will be a good promotion for the Hereon projects in digital twins.
Yeah, and the reason I brought this up actually was because all of these different observatories, they started by purchasing computers, hardwares. They were installing our software, they had training on it, and with the new editor approach, everything is centralized. So the same model now is just a button away, and then you suddenly simulate on European cloud computing and high-performance computing. So no more computers in your back room and the connection problems. So I think that's what we can be proud of that achievement.
I can only confirm we are really proud because we started from the zero. We had only ideas when we started. And in order to see where we are now, you're just welcome here in the corner to see the showcases, because from zero we started with already active showcases for the decision makers. And of course, all other developments, they, as already mentioned by Yann, are welcome to register and join to the EDITO infrastructure and to put their example, their data and showcase there. You are really very welcome to join the EDITO infrastructure or to join the EDITO.
Is there any more questions in the audience? If not, there is one in Slido that is a very focused one about what type of models are used for nature-based solutions, especially for mangroves. So it's a question to you.
So for hydrodynamics, we use schism and WWM. So it's for wave. And for morphodynamics, we use X-pitch.
In general, just to be clear, if you want to make the nature-based solutions, you need to integrate in a clever, multidisciplinary way the different models, because the nature-based solutions are dependent on the physical factors. And in order to use that for the different areas, we use the hydrodynamics models. In some cases, for example, for the mangroves, they are schism, they can be delta, they can be Scheifem. They have to be connected with the wave models because the seagrass is actually depressing the wave action, so the wave models are important. The sediment dynamics model, because the nature-based solutions are also sediment dynamics relevant, as well as water quality and biogeochemical. And within the lifetime of the EDITO-Model Lab project, we managed to do that, and we even go beyond, in which we not only integrated in a standard way the multidisciplinary models, but we enhance them with the artificial intelligence.
Thank you. We have still 4 minutes left. I would like just a very brief comment on you, especially thinking on the end users. And what was your interaction with them? Something that you learned also in the process of co-designing with them, or this activity of? Can you provide also some very snapshot of how you work it, or how do you feel about it?
I can start. So it was. There are different type of projects, as I said. There are ones that are purely end-user need-driven. This was somewhere in between. We had a technology push that we had to demonstrate along European Commission mission lines. So we had a starting point. We didn't start from zero, that what do you want to protect, which species. So we had a starting point, and our main goal was to make it relevant. And that's where this co-design phase happened, and it was really local. We did include higher level organizations, for example, environmental agency in the EU scale, but the real applications were discussed locally, and I think that went completely different for all of us. But in our case, as I just showed here, for example, we are now in the happy phase that we present something to the end user, one of them, and they are thinking on how to use it in their processes. So I think that's really when I feel proud that, okay, we did something. But I let, of course, my colleagues to express as well.
Hello. From the microplastic side, I can say that the model that we have been developing, it's actually an outcome of another project that was prior to the EDITO project. And that was a CLAIM project. And CLAIM was about cleaning microplastics. So there were different technological solutions implemented and a lot of interactions with actually people from the wastewater treatment facilities, and these areas were organized to see how the cleaning can actually benefit them in the microplastic action. And then the modeling was seen as a kind of component to identify where microplastics aggregate in the environment. So where you could, where action is actually needed. So in that sense, we had interaction with stakeholders, but yes, it's a tricky question. So of course, this was kind of seen. I mean, there were also nature conservation agencies included, which evaluated our validation efforts and so on. So in that sense, it was kind of done together with stakeholders. So.
Okay, then I don't mind. Yeah, as mentioned, it doesn't matter what is the application. At the beginning, stakeholders or users, they can be skeptic. But we can think of all these, our applications, as win-win situation. We need their input, their knowledge that we don't have as scientists. But then when we develop tools, then based on their knowledge and input, they can use these tools for their purposes of on their decision making. And this is how it goes. For example, we talk with stakeholders, with decision makers, with federal agency. We were aware that some of the what-if scenarios that we develop, they are not realistic and that they cannot be implemented easily, but still they can be used for decision making, they can be used for assessing the impacts. In some other cases, for example, connected with the bilateral project that we had with Africa, with Ghana, we went there. We had also stakeholder workshop. We went really to the local places, communicated and contacting with people, bringing also them in our facilities and working closely together. So this is also the very important within the digital twin technologies, that it incorporates together scientists, IT developers, stakeholders and users for having a better ocean.
Okay, thank you very much. So we close our, do you want to say something?
Just a final word about the users in our EDITO-Model Lab project. We defined several categories of users, and for sure we developed this what-if scenario really for the end users, decision makers and so on. But most of our users at the end in EDITO-Model Lab will be also the scientific community, the developers of model and so on. So that we have a large diversity of users, and of course it's very important to focus on the stakeholders and the final users with this kind of application. But we also expect to have much more collaboration, at least with the model developers and product developers at the end. So that's it.
Okay, thank you, Yann. So thank you very much. I will ask you to give a big round of applause to our colleagues of the EDITO-Model Lab. And we will be around, so you can ask more questions when you find them. Okay, thank you.
So thank you very much.